Hey, 42 here. The corner of the universe that we live in is pretty quiet. There's nothing nearby likely to explode, swallow us up, or just generally try to ruin our weekend. But that's not to say that there aren't some terrifying things out there in the darkness that would make you cower under your bed with Mr. Fluffles, and hope that the solar system is just how you left it when you finally crawl out again. Today, we're looking at some of the most terrifying monsters we have ever discovered in the universe. Brontophobia is the fear of lightning, and there are estimated to be 24,000 lightning-related deaths a year. A typical lightning strike is about 30,000 amps, and even these can vaporize metal and fuse sand into glass. But a team at the University of Toronto have found the highest electrical current that has ever been measured, somewhere out in space, measuring an enormous 10 to the 18 amps, which is the same as a trillion of our lightning bolts here on Earth. So, what's causing this massive surge of electricity? Has Thor been on the steroids again? It's actually down to a gigantic black hole at the core of a galaxy called 3C303. The magnetic fields that it produces are moving and interacting, and this is what generates the massive electrical surge, like a supersized dynamo. And if we do manage to all avoid being struck by lightning, that doesn't mean we're safe from all burning up like Walmart on Black Friday. In every galaxy there are stars moving so quickly that they are able to escape the pull of gravity and race through space unchecked. Stars, much like those of Hollywood, are single much less than you might think. About half the stars in our galaxy form a binary pair, where two stars orbit around each other in a beautiful cosmic dance. Our sun unfortunately has to sit on its own in the corner like the ugly fat kid at a dance. So sometimes when these binary pairs are dragged towards the large black hole that always sits at the centre of every galaxy, one of the stars can be ripped free and hurled off at a speed of 10,000 kilometers per second. The other is swallowed into the black hole, like when that lonely fat kid finds the buffet table. And if such a rogue star came anywhere near our solar system, there's not very much we could do to stop it, as it burned us up and its enormous gravity pulled everything out of orbit. The likelihood of this is, fortunately, very low though. So, if you do see a bright dot in the sky, don't stop doing your homework and wait for the world to end just yet. It's probably just an aeroplane, or a really shiny pigeon or something. At some point, our galaxy is going to collide with the Andromeda galaxy. So make sure that you don't put anything in the diary for about 3 billion years in the future, just in case. When the two do combine, the black holes at their centres will either merge into a supermassive black hole, or they will form a binary pair, just like the stars we mentioned earlier. The compressed matter around these supermassive black holes becomes a quasar, which stands for quasi-stellar radio source, since they emit similar electromagnetic radiation to stars, including radio waves and visible light. They are incredibly bright. You'd need 100 Milky Ways just to match them. Just one quasar is enough to use up our entire stockpile of sunglasses, but the huge large quasar group, who names this crap, is a string of 73 quasars that spreads 4 billion light years across, making it the second largest structure in the known universe. The biggest of which is the fancily named Hercules Corona Borealis Great Wall. Okay, that's slightly better. A group of 14 gamma-ray burst whorls, which are very bright objects caused by dying stars. Both of these gigantic monsters you will want to avoid if you value your eyesight. Sometimes when you have a massive star, it goes supernova and collapses under its own weight and ends up as a neutron star, which are hyper-dense balls about 11 kilometers across. Yet, they can have the mass of double our sun. How is this possible? How can you fit that much into such a ridiculously small space? Are neutron stars made by IKEA? No, there is a scientific explanation. As anyone who has ever tried to pack a week's clothes into their hand luggage will tell you, if you push things together that tightly, they will push back. Those same people will probably tell you it wasn't worth the £11 they saved on luggage fees when their underwear and spare tea bags burst all over security control. The neutron stars are, unsurprisingly, made up of neutrons, When you pack them together that tightly, the only thing that stops it collapsing into a black hole is this repulsion between the particles, which only becomes powerful at such immense densities. A neutron star is so dense that just a matchbox-sized amount would weigh about 13 million tons on Earth. Occasionally, these neutron stars become magnetars, which isn't a Pokemon, where they produce such a powerful magnetic field that they even alter the vacuum of space around them. They are the most powerful magnets in the universe. So, if you do visit one, remember to leave behind your credit card and take out your nipple piercings. Ouch. Stars are messy little things. Not only do they pump out a wide spectrum of electromagnetic radiation, but when they are finished, they often leave behind huge clouds of dust called a nebula. If you were up close, you probably wouldn't notice it since it's spread out more thinly than any artificial vacuum we've ever made on Earth. But from far away enough, we can spot what remains of the star. And if we watch for long enough, we'll probably see surrounding solar systems complaining about their messy neighbour as it starts to gobble up their planets. These nebulae can be hundreds of light years across, and whilst our clouds on Earth are often fat, cute and fluffy, these space giants form strange and twisted shapes that truly look like monsters of the universe. Just 7,000 light years away, within the Eagle Nebula, there are the towering space worms known as the Pillars of Creation. These dark clouds will slowly draw together and form the stars of the future, where their simple hydrogen will heat and eventually produce all the rich and complicated material like we see here on Earth. How about a real monster this time? Just when you thought that space was quiet as the grave, you hear a horrifying moan. It's a zombie star. I'm not sure you can defeat this one with a cricket bat to the head, so probably best to just head down the Winchester, bar the doors and hope it doesn't find you. This is the result of a binary pair of stars, where one of them is a white dwarf. A white dwarf is similar to a neutron star, except that the original star didn't have enough mass to fully collapse into a neutron star, so you're left with a ball of mostly carbon and oxygen. There's no fusion reaction going on anymore, so it's just a corpse left out on the porch, slowly losing its heat. But when you have a binary pair, it's possible that the white dwarf will leech energy off its partner and slowly regain the mass it needs to come alive again, kick-starting the fusion reaction, probably resulting in a final rampaging supernova. Such stars are fittingly known as zombie stars. It's a similar story for vampire stars, also known as blue stragglers. We discovered stars that seem to be much hotter than those in their local area, and when it comes to stars, hotter means younger. But since they all formed from the same nebula, how can this happen? Well, like with the zombie stars, we think one star sucks the life out of another, giving it that youthful glow that we all long for. So, put down your quinoa cream, pour away that disgusting kale juice, and stop going to bloody Zumba class. All you need to do is eat a star. And lastly, a weird one. If you were an interstellar explorer living off vacuum-dried protein bars and drinking your own recycled liquids, there are probably times when you stare out into the frozen blackness and think, God damn it, I need a drink. Well, ask and ye shall receive. Sagittarius B2 is a 150 light-year long booze stop. This dust cloud within the Milky Way contains vast quantities of ethyl formate, which give it the unique flavour of raspberries and rum. There's also enough ethyl alcohol there to get everyone on Earth drunk for trillions of years. So, if NASA are really worried about the public losing interest in the space program, just tell them that for a few $1 billion, we're going to build a ship and go and raid God's liquor cabinet. Maybe this is why we've yet to meet alien life. They're all waiting for us to join them at the gigantic bar in the sky. With all these monsters creeping around in space, perhaps we should be grateful that all we have to deal with is one sun, the occasional asteroid, and all those other weird monsters, people, that we've managed to get stuck on this little rock with. I think we can all raise a rum and raspberry to that, right? Thanks for the view, subscribe for more. 42. If you think making a murderer was shocking, you ain't seen nothing yet. It's estimated that every year in Japan, hundreds of people are wrongfully convicted for crimes they didn't commit. There are hidden oil wells all over Los Angeles. These secret oil wells are hidden right in plain sight. Some are next to schools and shopping malls,